Hello. Okay. Perfect. So my name is Néstor. I've been working with WebRTC.ventures for the past 2 years probably, mostly on WebRTC related projects. So I saw a lot of hands raised when everyone asked how many have used WebRTC. So maybe some parts of this talk will be a little bit boring for those of you, but maybe you will learn 1 or 2 things. For the rest, it should be really fun. Yeah. Okay, so what is WebRTC? WebRTC stands for Web Real-Time Communications, and it's basically a set of JavaScript APIs that allows you to basically send media over one peer and another without having anything in between, directly between the 2 peers. You mostly see references in browsers, but actually it can be used in any device that implements some specific protocols. And those protocols are SDP, Torn, Stone, and some others, which we won't see in detail here. So yeah, and these 4 APIs are the ones that conform WebRTC. As you can see here, media stream, RTC peer connection, RTC data channel, and GetStats. And we will see a little bit of each of them. So let's start with media stream. Media stream is also known as Get User Media or GOM. And this particular API is the one that you use to get the access to your devices, to your microphones and cameras on any of the devices that you're using, your cell phone, your computer. And in return, it gives you a stream of data that then you somehow have to send to the other peer. Okay, so the third point here is that, as I mentioned before, WebRTC is not a standard yet. This means that each browser, each vendor has some prefixes on how they name the things. Mozilla Firefox uses the MOZ prefix. In Chrome you will see WebKit, and Internet Explorer used to have an MS prefix and some stuff. So there are definitely some inconsistencies between browsers that you have to deal in order to get WebRTC to work between browsers. And this can get a little tricky, so the WebRTC Foundation actually came up with a different project called Adapter.js that takes care of all those details. And it basically exposes an API like if it were standard already. WebRTC is, hopefully, you will get a standard this year, but they said the same last year, and here we are. So, yeah, in the meanwhile, you can still use Adapter.js and work if it were standard. So here is a little bit of code, and the first line is one of the examples that I think I said. You see, the first one says navigator.getUserMedia, but the second one says webKit.getUserMedia. That's the one that is accessible on Chrome. But if you're not on Chrome, that object won't be defined, and then you have to use MOZ.getUserMedia. And this is just an example. There are a lot of other inconsistencies between the browsers. And the rest of the code is just to get the access to your devices. In this case, it's your camera, but no microphone because you have the audio on false. Okay, sorry. So the second API is RTC peer connection. And this one is actually probably the core of WebRTC. With GetUserMedia, you get the data, the streams that you want to send, but you need to send it to someone. And this is where RTC peer connection comes into play. RTC peer connections defines a way to recognize that there is another peer somewhere, that you can reach that peer and send information to them. and it handles a lot of stuff. SDP negotiation is the actual process of figuring out who is out there that wants to receive my information. It stands for Session Description Protocol. It is a really ugly protocol, but you usually don't have to deal with them with it directly, thankfully. But sometimes you do. Yeah. It also handles mailing calling, network issues, package loss, and all that, and echo cancellation, and a lot of other stuff. And one thing in particular that handles about the network is NAT traversal. NAT traversal is, and actually I will talk about this particular item in a little bit more detail. So WebRTC is sold to you as peer-to-peer, as, okay, you don't need anything in between. And this is kind of true. In some scenarios where you have a public IP address and the other peer also has a public IP address, then you can directly connect with each other. But, and this is the case on this image. These two peers are accessible one to each other without doing anything. I mean, if you have a public IP address, you know exactly who the other peer is. And actually, now that I have this image here, I will briefly describe the signaling process. This is not exactly part of WebRTC, but you will usually read it when you are investigating about WebRTC. The signaling process is actually the exchange. It's like a handshake where you tell the other person or the other end that you want to establish a call. And this other person or endpoint tells you, okay, I'm willing to accept that call. It's not part of WebRTC because you can use whatever medium you want to do this handshake. So that's peer-to-peer, right? If you have two public IP addresses, or maybe you are on the same LAN, local network, then you know who is who. But oftentimes you don't want to communicate with the person that is right next to you using a video call. You will do it in different scenarios where you probably are in a private network and you have a private IP address on your machine, and that definitely doesn't work for WebRTC. So you need a way to know your public IP address and send it to the other peer. And this is where one particular item called a stun server comes into play. The stun is a mechanism to basically know what your IP address is. You just ask him, you send a package. The only thing that it does is that you send a package to it, and then it reads the HTTP package and sends back to your IP. And now you know a public IP address, and then you can communicate with the other peer. And these two scenarios where you have a public IP address or you use a stun server normally covers like 80% of the cases. So with just this, you're able to get in a call with 80% of the people that you try to do. For the rest 20%, it gets a little bit complicated. There is something in networking called Symmetric NAT. Basically, what it does is that depending on what application you're using to access the internet, it assigns a different port in your machine and a lot of other stuff. And in that case, sadly, you cannot use a stun server. That's definitely not enough. And this is where the peer-to-peer part stops being true. In that case, you need something called a torrent server. I think it stands for something relay. Yep. The RS relay, which basically means that you have to have a different server, and all the data that you're sending and receiving will pass through that server. And that obviously costs bandwidth, and then you will cost money, but it's necessary. if you want to handle the other 20% of the cases. Yeah, now that we know that not always it is peer-to-peer, we can move to the third API. The third API is RTCDataChannel. This one is kind of interesting because, and it's like no one really uses it. I mean, it's like it's on the side. When you talk about WebRTC, this is forgotten, and everyone talks about video and audio. But RTCDataChannel is actually really awesome because it exposes like a WebSocket API, really similar to that. But the main thing is that you can send anything through it. With RTCP Connection and get user media, you get audio and video, and that's it. But if you want to send files to the other person and still have the benefits of WebRTC, that it's peer-to-peer encrypted, and that is supposed to be fast and all that, you can use RTC data channels. And one characteristic that is really important about RTC data channels is that it can be either reliable or unreliable, just like TCP and UDP. And the nice thing about this is that it adapts to your use case, depending what you want to do with it. You can decide on which mode you want to use it. So if you want to have a web torrent or file sharing, you have to ensure that everything gets to your end, and you need to have a reliable channel. It doesn't matter that it's a bit slower than the non-reliable one. But in gaming, you don't really care if one package or two packages get lost, and you can use unreliable. So this adapts to your use case. And the final API, it's GetStats. I won't go into more details about this one. I will show you a little example of that. Okay. So right here, I have a Hangouts Windows. If you haven't used Hangouts, it's basically a communications tool, video calling. And it uses WebRTC. And this second page is an internal page of Chrome called WebRTC Internals. And it shows some statistics. And this is using the GetStats API. Obviously, the GetStats API only gives you 1 point in time. And then you can use multiple values to draw something nice like this. And this is really helpful if you want to know about how your app is being used, in which cases the network quality is poor, and stuff like that. So you can always use GetStats. And maybe you noticed that there are a couple of them that has the GOOG prefix. Those are Google Chrome specifics, and you won't find those on if you use GetStats on Mozilla. But you can still get some really nice statistics like package loss, bit rates, and all that. Okay, so those are the 4 APIs, and they combined can be used to start a call. Don't worry if this might seem scary. You will see it in action in a moment when Herman codes a little app. This is basically the set of API calls that you have to make to establish the actual call. You start by using getUserMedia to get your audio video, and then you get the stream, create an offer. The offer is actually like the intent that you're saying, okay, I want to start a call. And then you send that to the other peer through the signaling server. As you can see, that doesn't depend on WebRTC. It can be anything. Then the other peer receives that information and decides to answer it. And then the same thing happens. On the other end, you need to get your media, using getUserMedia, you get a stream, and then you send that stream back to the first peer. And magically, you have a video call. yeah, that's why their happy faces are there. Okay, so this is really nice, at least it is for me. Hopefully you will find it also nice. But why should we care about all this? I mean, the whole WebRTC thing. And there are a couple of things that have happened in the past years that might seem like indicators that is something really powerful. And I have some of them here. First of all, industry endorsement. Things like the traditional meeting services like WebEx and GoToMeeting are starting to use WebRTC in their services. Where they use, previously they used Flash or anything else or just voice over IP. They now use WebRTC or intend to use WebRTC really soon. A really interesting case is Facebook Messenger. Probably not many people know that Facebook Messenger uses WebRTC, but the thing is that Facebook Messenger has like 900 monthly active users as of last year. Obviously, not all of them are using video calls every day, every minute, but it's still a huge market that, without knowing, are using WebRTC. The other nice thing is, like Erin said, in Internet Explorer, WebRTC doesn't work. Edge is starting to get there. I mean, Microsoft decided to implement a parallel standard called ORTC, but in the way they figure out, okay, they are both awesome, so we'll make them interoperable, and you can use either. So ORTC, which is the alternative, is actually good for WebRTC, because it means that you can use it now on Edge. And finally, the other bad guy was Apple, that didn't want to commit to WebRTC. So finally, I don't know, a couple of months ago, they started adding WebRTC support into WebKit. This doesn't directly mean that they will add it to Safari, but it's a really good chance that they will. So yeah, this means that every major browser will support WebRTC pretty soon. And besides the industry endorsements, as of last year, it was over $1 billion funding, $1 billion in funding for WebRTC related projects, either for companies that give services that use WebRTC, and not just. One thing that is really important is that WebRTC is not a core feature. I mean, it doesn't have to be like the center of your business. It's just a technology that you can use as just part of the rest of your application. So there are a lot of companies that can benefit from it. And finally, and I think this is the most important point here, is that the way we consume data, media, is constantly changing. I mean, a couple of years ago, you used to, well, maybe not us, our parents, used to have just newspaper. Then we get to follow someone on Twitter or watch live streamings or things like that. And right now, live streaming is actually the most important thing. And one of the things that endorsed that was a couple of months ago, Facebook launched Facebook Live. It used to work previously to that, but it was just for some people. And now anyone can use Facebook Live. And this means that anyone is potentially a broadcaster and can get in touch with a lot of other people out there by just using Facebook. Probably, it's pretty sure that they use WebRTC, and even if they don't, what is important about Facebook Live is that it's creating a way to communicate, to put publish content to the world. And the thing is that the users will get used to that. And it doesn't matter if you are on Facebook or any other page, the user will want that same kind of interactions with everyone. And this is where WebRTC is really important, because you can use it to build this kind of software outside of Facebook. So yeah, pretty good. At least I see it. Okay, so this is all nice and really exciting, but there are a lot of moving parts when you actually try to implement a WebRTC application. The signaling process, as we mentioned, it doesn't have to do anything with WebRTC, but you still have to define what you're going to use. Either you are going to use SIP, WebSockets, XMPP, or anything else. So it does have a cost of implementation. Stone and Torn servers, you either have to host them yourself and maintain them, or use a commercial service that has them. Either way, it is something that you have to consider too. Multi-point control units. This is particularly important if you want to have like broadcasting. You want a couple of streams to be viewed by thousands of users. Because one thing that is really famous of WebRTC is that doesn't really scale well just by itself, because of its peer-to-peer nature. It means that if you are on a video call with 10 people, you're sending actually your data to 10 times, and you're consuming 10 times the bandwidth of one person. So in those scenarios, it's like things that MCU are important, and of course you have also to either implement it yourself or use a commercial solution. Media recording, code quality, zip trunking if you want to also enable users that have a landline or voice over IP to communicate with WebRTC users. So yeah, there are a lot of things that you need to consider to actually implement a WebRTC application. And now you will see how a simple WebRTC is implemented. My colleague Herman will help with that. So yeah, that's it from me.